Hello, my name is Matthew Braddock. Today I'm going to be talking about GeoGebra. This is math software that does a variety of things from algebra and geometry up through calculus, also does statistics. This software is free and open source, so it's also cross-platform, so Windows, Mac, Linux. There's applications for Windows tablets, Android tablets, iPads. They're starting to come out with mobile applications as well, so it's available on a wide variety of platforms, and again, it's free and open source, so anyone has access to it. It also has a HTML5 web application as well. It's also a Chrome extension too. Again, it's everywhere. So I'm just going to go over some of the basics. We're going to create some things, just kind of see how they work. Mostly doing this as using it as a demonstrative tool in the classroom. Students can definitely use it. It can be very interactive for them. But for the purposes of this presentation, it's going to be how can I use this to animate math and make math easier to access for my students. So here's the main window. Over here to the side we have an algebra window. This is where any objects or items will show up. Anything that we have created, points, lines, equations, anything like that. The graphics, we have an axis here. You can make a grid if you want. You can get rid of the axes in case you're just messing around with geometry shapes. We also have the input bar down here at the bottom. You can create a lot of things up here. Sometimes, if you're typing in a function or something like that, it's easier to use the input bar. Up here again, we do have a wide variety of different things we can make that are just kind of built on here in addition to all the commands. So points, you can put points on an object, intersections, different types of lines, segments, rays, all different types of lines, polygons. You can create different types of circles or parts of a circle, ellipse, hyperbolas and parabolas. Angles, you can do reflections and rotations, text and stuff, slider checkboxes and input boxes. These are super things that we'll be using a little bit today, and moving graphics around. So the biggest thing here, as with any math, is you have independent objects and dependent objects. And you need to create anything that's independent, anything that you want to be able to change, and then make the stuff that depends on other things. So I'm going to do just a basic example to start. We're going to do graphing a quadratic function. Quadratics are usually ax squared plus bx plus c. To really show how different things, different quadratics, we want a, b, and c to be something that we can change. So these are going to be independent things. They're just numbers. So we'll start with making a equal 1, b equals 0, and c equals 0. So we're just typing these in the input bar, and we now have numbers. They don't do anything right now. They're just numbers. And so if I want to make a function, then we can do function notation, f of x, ax squared plus bx plus c. We're actually going to put multiplication in here just to be clear. It is a times x squared plus b times x plus c. The a, the b, and the c are the numbers we already have created. The x is our variable, which we've indicated in our function notation. And so if we click that, as we can see here, it is 1x squared plus 0x and then plus 0, which they don't show. Okay, so we can change these. We can make this 2. You see everything updates. This is kind of, really tedious to do though. So clearly there's got to be a better way. Well, with our independent objects, like numbers or angles or things like this, we can change them. If you press these buttons, it turns on these little sliders. And so you can grab here, and now we can change the number this way. Definitely change the values. Let's see. Let's go to. So there we go. So using sliders gives you the ability to change values of independent objects very easily, kind of intuitively. You can also change how these sliders look if we go into the properties of these numbers. The interval here, so -5 to 5. We can go ahead and make this a little bigger, -10 to 10. Maybe increment in halves, so it's not super small numbers. We can do that for all of them real quick. And then take a look at how this works. Okay, so now it increments in 0.5s, and we can go a little bit bigger and a little bit smaller here. I probably don't want to go that big. There we go. So, there we go. We can do more things with this. Say, for instance, we want to know where it crosses the x-axis. We can make some points here. If we know the quadratic formula, of course. So we can say our first point, let's call it S. This number, we're going to make a number S. And S will be part of the quadratic formula. For the functions you're used to, there's abbreviations for them. So square root is SQRT. If you are familiar with LaTeX at all, with math, then you know some of these. So we'll just type this in here. That did not. No. Hold on. Then put parentheses in the right spot. So parentheses, just like on your calculator, are very important. So this is 2.23, which is, should be about right here. And then I'm going to cheat and take this and make another one, call it T. The same thing, except change it to minus. Okay. And so that's -0.9, which is about right here. And then I can make my 2 points. So first intercept, I'll make it a capital S, little s 0. So the x value will be whatever s is, 2.23. And 0 will be the y, which is, I'm going to put it on the axis. So there we go. We'll do the same thing with t. It'll be little t and 0. So now if I move these numbers around, these numbers also will go with it. And as soon as we go above the x-axis, we have complex numbers. It doesn't like that, so that works. One of the nice things about this too is we can start messing with this. We can get rid of the label so we don't have a little tiny f up there. We can change the labels. So t here, let's say I want to say whatever the definition is. So we can say it's the value. It's going to tell you exactly what that is. A little bit more descriptive. We can also display what the function is if we wanted. So f of x equals whatever the function f is. We can make it look pretty in LaTeX. Right, so now we have what the function is. Changing these numbers around. You can even say x-intercepts are s and t. There you go. So there's a lot we can do here. This is pretty basic, again, just how we deal with dependent and independent objects. But there's a lot you can do here. If we don't have these, let's say g of x is x squared minus 4x plus 5. That's one we made up. There's no independent objects here, so we can just, it doesn't depend on anything. We can change it all we want. And so we can do an input box and say g of x equals, and it's going to be linked to g. So we can actually just change this right here rather than having to go over here and mess with the algebra. And this is great because you can actually upload these applets to GeoGebra Tube, which is kind of like a hosting for all the applications, and be able to have students look at this. And you can hide this because sometimes students don't need to see that. They don't need to see all the inner workings. They just need to see what you put out here for them, and so they can change it right here. Okay, so we're looking at another example with some more stuff than just this. So let's go ahead and there we go, destroy all that. Yeah, let's get rid of this box. Get rid of the input box. Alright, well, we'll worry about that later. Okay. Let's just open a new tab then. Alright, so I want to look at a specific problem. So here's a problem that my algebra students get to do. This is linear regression, so they have some data, relating the amount of time studying and what test scores are. Linear regression is something they can do on TI-84 calculators. Showing calculators on the computer, though, or just projecting it doesn't always look as great. And we like to make it look nice and pretty. So we'll go ahead and I'm going to make the font a little bigger so we can see things easier. There we go. And we're going to look at the spreadsheet. And we get to type this in just as it was, so I'm going to type in all this data really fast. Okay. And then we'll make things happen pretty quickly. Okay, so hopefully students, they'll look at the numbers and say, well, it looks like it goes up the more time you study, which should make sense. So what we want to be able to do is we want to plot the points on here. And so we need to turn these into points. So we just highlight them all. Don't do that. So highlight all the points. Then we go over here and we want to make a list of points. Okay, so they need to have a name. Call it test. We'll just call it list 1. Keep it what it is. That's okay. And you don't see anything. Well, that's because our points are not on this scale. So we can just zoom out if we want, or we can make this very specific. From 0, the highest one we have is 60. So we'll go to 70. And the Y's need to go up to 110. The issue here, you'll notice you don't see the axis anymore. So we'll go ahead and just -5, -5. And now we can see the axis. Alright. So we have a bunch of points, A through I, or A through J. And so the students know this is linear regression. And they need to come up with the equation. So they do line of best fit, which we can do as fit. And you notice that once you start to type stuff here into the input bar, it gives you suggestions based on what you've typed. So we can do fit line. We want to input a list of points. And our list of points, what we called was list 1. So that's what we're going to type, list 1. And there's our equation. It goes as best it can through those points. Oops. We scoot out and we get our line here. The other way we can do this is we can go to object properties and display the value, of course. And so now they have their equation, and it goes through here. And so it's very, very easy to see, pretty easy to type in. Again, very good. Another thing we can do, let's go ahead and get another window open here. We're also going to do some stuff with some statistics. Another application here. So here's another problem. 30 people are asked to rank a new soda from 1 to 10. Here's the results. We need to find the mean and standard deviation. So it looks like it's pretty, pretty high. People pretty like it pretty much. So we'll do the same thing. We need to put in our data. So let's see how fast we can get these ones in. one likes data entry, do they? Alright, so there's all 30. We need to do some statistics. So we have one variable analysis. And do we need to select the points, or will it just analyze what A is? Well, we need to actually select our points. So take our points that we want to analyze. Alright, we list all the numbers from A1 to A30. Alright, so here's a histogram. So we can see most of the numbers are higher up here. Right here, the sigma x will give you statistics. So, make this a little bit larger to read, hopefully. Not so much. Okay. One issue with making the font higher, some things don't scale properly, so the numbers get run together. But we have our mean, 8.0667, and our standard deviation of, we want this one, 1.3113. So, this gives us our information. You can do lots of statistics on here. We have histograms, we can do box charts, box plots, dot leaf, stem and leaf, like lots of different options for statistics that you would see in algebra classes or even AP statistics, depending how much you're doing. We have two variable regression, probability calculators are on here as well. Changing your mean and your standard deviation. So there's a lot of useful tools in GeoGebra. One thing we didn't look at, we can check real quick, because we have a computer algebra system which can do some pretty neat things. Let's see if it'll do this offhand. No, that one didn't factor, did it? Alright, so our computer algebraic system here can do some higher level calculations. We can do integrals. It does calculus. It does anything you need it to do. Solve, factor. You can do numeric evaluations, or it'll give you fractional answers, derivatives, probability calculators. Other thing it has here is 3D graphics. As we're opening up a bunch of stuff, it's hard to see everything. 3D graphics, I myself have not played with too much, but you have a bunch of new things you can do here. Intersect surfaces, make a plane, pyramids, cone, prisms, spheres. This is a relatively new feature, I think within the last 8 months. GeoGebra is very powerful. Again, applications from anywhere from Algebra 1 up through, calculus and beyond. So it's a free tool, unlike other ones like Geometry Sketchpad, and it is extremely powerful.